Welcome to this explainer. Today, we're diving straight into a fatal mistake. You know, the one that literally costs Cambridge biology students their ASR grade in topic 4.2 before they even finish reading the question. Have you ever walked out of an exam feeling totally confident, only to get your results back and realize you completely missed the mark? Well, we're cracking open the complete concept breakdown for osmosis and the movement of water by water potential, and I'm going to show you exactly what examiners are looking for. So, why do candidates consistently lose marks on osmosis calculations? Look, the difference between an average grade and a top-tier mark really comes down to one thing: precision. You can spend hours memorizing textbooks and watching generic tutorials, but if you don't understand the exact academic benchmarks the syllabus demands, you're just leaving marks on the table. The assessment framework prioritizes analytical depth over superficial breadth, which means you absolutely need to know how to show your understanding in the exact format the examiner wants. Going straight to the source, principal examiner reports reveal there are 3 devastating traps students fall into when it comes to the movement of water by water potential. We've analyzed years of these reports, and these 3 specific errors show up time and time again. They're the exact reasons why otherwise brilliant students find themselves stuck in lower mark bands. And here they are: forgetting units and calculations, confusing your terminology, and giving answers that aren't specific to the context. These 3 things will tank your score, no matter how well you grasp the general concept. Let's break it down. First, calculations without units, they are essentially meaningless to an examiner. That's an instant dropped mark. Second, swapping out precise terms for vague descriptions loses you those core knowledge and understanding marks. And third, if your answer doesn't specifically address the stimulus material, like the exact plant tissue data they gave you in the prompt, you forfeit the application marks entirely. Section 1. Core Concepts, Mastering Terminology. Let's look at our foundational architecture and see how this builds. Because examiners strictly require precise definitions and causal relationships, you simply cannot construct a high-scoring extended response on a shaky theoretical foundation. This definition right here has to be your absolute anchor. Water potential is the potential energy of water per unit volume relative to pure water in reference conditions. You must define your terms clearly before ever using them in an extended response. The principal examiner reports explicitly state that candidates consistently confuse key terminology here. If you define this correctly in your mind and explicitly write it on the paper, you're setting the perfect stage for a top-tier answer. Candidates referencing cross-topic connections achieve significantly higher marks. That's a direct quote from a principal examiner report. In just a moment, I'll show you the exact examiner clue that changes an answer completely. But first, you need the procedural framework that makes that clue super obvious. Students who demonstrate connected conceptual understanding, the ones who see how water potential relates to cell membranes or whole plant transport, are the ones to get those top marks. It's all about those cross-topic connections. Section 2. Technical Methodology, the Method Marks Strategy. Let's look at a standardized sequence where you're awarded critical marks simply for following the right process. Exam questions on unfamiliar contexts can be terrifying, right? But if you have a technical methodology, you can systematically harvest marks even if the final answer totally eludes you. By systematically applying these 5 steps to any unfamiliar context, you guarantee that you are hitting the assessment objectives for logical, structured reasoning. Step 1. Deconstruct the question. Know exactly what is being asked. Step 2. Extract relevant data from the stimulus materials. Step 3. Select your analytical framework. Step 4. Execute with clear notation, meaning show all your working clearly. And finally, Step 5. Present your findings with correct terminology. This is your absolute blueprint for maximum credit. Section 3. Statistical Analysis in Osmosis. Escaping average mark bands also requires flawless data interpretation, which brings us to the appropriate statistical tests. In A-level biology, you aren't just describing osmosis. You're often required to evaluate it statistically to prove that the movement of water you're observing isn't just due to random chance. Knowing exactly when to use a t-test versus a chi-squared or correlation test ensures your analytical depth matches the examiner's expectations. So use the t-test when you're comparing means between 2 sets of continuous data, like the mean mass change in 2 sets of potato cylinders. Rely on chi-squared for categorical data and apply correlation tests when you're looking for relationships between variables. Knowing which tool to pull from your toolkit is honestly half the battle. Section 4. Interactive Challenge. Spot the error. Okay, let's put you in the examiner's seat with a quick pause and predict moment to see if you can spot the flaw in a typical student response. Imagine you've got the red grading pen in your hand right now. Take a look at this. The flawed answer says, water moved into the cell because of the concentration. It sounds okay, right? But it gets 0 marks. Now look at the top band answer. Water moved down the water potential gradient into the cell. That phrasing secures the mark because it uses precise syllabus terminology instead of vague descriptive words. It proves to the examiner that you understand the actual causal relationship driving osmosis. So, the crucial takeaway here is this exact framework. Start with the concept, back it up with extracted evidence and data, apply scientific reasoning, and finish with precise examiner wording. If you follow this exact pipeline for every explain or describe question, your answers become incredibly robust. You are quite literally spoon-feeding the examiner exactly what they are scanning for.
Section 5, Evaluation and Practical Skills. Beyond the theory, practical work in osmosis develops experimental skills that are heavily scrutinized. You'll be asked to evaluate the quality of evidence, which is a higher-order assessment objective that truly separates the good students from the great ones.
You have got to follow a sequential flow in your practicals. The requirements are strict. Select the right apparatus, follow instructions precisely, make accurate observations, use suitable tables, identify anomalies, and draw evidence-based conclusions. Examiners want to see that you didn't just passively follow a recipe, but that you actively engaged with the experiment, recognized when a data point was way off, and knew how to structure your findings logically. Notice the massive shift here from lower-level descriptive analysis to higher-order evaluative analysis. A descriptive analysis just points out what happened, maybe noting some similarities. But an evaluative analysis requires you to compare similarities and differences, highlight the limitations of your experimental setup, and even propose alternative interpretations. This requires you to identify assumptions and justify your conclusions. And let me tell you, this is where the big marks live. Section 6, the problem-solving loop. Let's move to the ultimate strategy for handling complex, totally unfamiliar data scenarios under exam pressure. Because when you open a paper and see a bizarre graph about water potential in a plant you have never even heard of, you need a system. This deconstruct, solve, evaluate loop is your lifeline. 1. Identify the given info. 2. Break it into logical steps. 3. Solve systematically. 4. Check for reasonableness. And 5. Make justified recommendations. By explicitly writing out your systematic working and checking to see if your biological conclusion actually makes sense, you ensure you capture every single available method mark. Section 7, Key Takeaways. All right, let's lock in the highest yield strategies from this explainer before you go face your next past paper. We've covered a ton of ground, but there are a few non-negotiable rules you absolutely need to walk away with today. Remember these 3 pillars. Number 1, never forget your units. Number 2, always define your terms before using them. And number 3, use the method mark strategy. Consistently applying these will immediately elevate your score and protect you from the common pitfalls that drag down so many capable candidates. Master these and you master the topic. But here is a critical question for you. You've mastered osmosis, but what if the command word traps you? You now have the perfect theoretical framework for water potential, but there is a hidden cause of lost marks that happens when you misinterpret the specific exam command words. Think about it. You could know everything about osmosis, but if the question demands you evaluate and you simply describe, you will score 0 marks for that section. It is a devastating trap. To ensure you don't fall into this final trap, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Join us in the next explainer, where we decode the exact command words that decide your mark band. You really cannot afford to miss that missing piece of the puzzle. See you there.